All right, so I'm not going to be talking about controlling my TV and a camera in my living room in Seattle, and I'm kind of wishing I had gone first now, but instead we're going to talk about serving HTML files over the internet, so that's exciting too. All right. Okay, so static web architecture, not just for hipsters. My name is Michael Bleigh. As David mentioned, I am the co-founder and CEO of DivShot, which coincidentally is a static web hosting platform as a service. I'm sure that has nothing to do with why I'm giving this talk. If you want to follow along on a laptop, although actually probably for the best, most people don't seem to have those out, dex.mbleigh.com/static web architecture. I'm mbleigh on Twitter if you want to follow me there. So let's talk. Request response is dead. What I mean by that is that the traditional sort of, I need content from a website, so I'm going to make a request and then it's going to give me back all the data I need, and then if that data changes, maybe I'll refresh the page or I'll click a link which will trigger a new request and the browser page will reload. That paradigm is dying, and I'm just going to go ahead and declare it dead. And the reason is that user expectations have changed. So people who are using the web now, they expect that if new data becomes available, that either is it loaded or at least notified about without having to refresh the page. Basically, users don't want to ever have to refresh. They don't want to have the page blank and reload and lose that context. They've become spoiled by Ajax and real-time and all of these wonderful tools that we have today. But most of our web applications are still architected like that traditional request response model is the only thing that really exists. Users want applications. They don't want sites. Even if I'm on a pure content site, even if I'm on CNN.com, the New York Times, I don't want that flash of blank page. I want relevant things to just pop in. The next page just loads instantly. I never lose that context. I always have new information coming in. So every site, whether it's a content site, an application, whatever it is becoming an application because of user expectations. So why do we still build web applications like the only model is that request response model? And if we're not going to, what's the alternative? So static web apps is sort of my proposal for that. And that is basically, in a nutshell, separating your front end and your back end entirely. I'm not talking about, I have an Angular app that's also served up inside my Node app. I'm talking about these are two completely separate applications that run on different subdomains, different web hosts, completely separate. So your typical traditional web application, the browser sends a request to a web server. The web server interprets that request and sends it on to a web application. Your web application connects to various data stores, Redis, Mongo, SQL, whatever it is, pulls the data that's needed for the page, generates the HTML using a templating language or however you'd like to do that, and then sends that generated HTML back to the browser, which is then rendered to the end user. In the static web app, the browser sends the request to a static web server. The web server basically just says, okay, here's an HTML file. I don't really care what the request is. Here you go. The JavaScript in the page is a little smarter. It looks at the characteristics of the request. It makes requests to separate backend services. That could be anything from a custom API that you've written to Firebase, Elasticsearch, CouchDB, any number of things. And it changes and manipulates the HTML of the page to represent the data once the JavaScript has received that information. So again, front end and back end, completely separate. There's also hybrid applications. That's things like Meteor, the Airbnb isomorphic JavaScript applications, using a proxy cache, which is where you have Varnish or something sitting in between your application server and the end user, and it's the entire page is cached and served. That's another approach you can take. I think it has some sort of long-term drawbacks that are similar to the request response cycles. So you might be thinking, I've heard of this. It's called a single page app. And that is the sort of common terminology. Everyone building these types of apps has surely heard this term. So why am I not calling it that? First, I just don't like it. I don't like that term. And terms kind of matter. To me, single page application sounds a lot like calling cars horseless carriages. It's defining what you're doing by what you're not doing. So this application doesn't have many pages. Let's call it a single page application. I don't think that's very descriptive, and I don't think that's very helpful in really helping people to understand what's different. So the term that I've come to start using is a web client. So what I mean by that is you have, for your app, for any given application or service, you might have an Android client, an iOS client. And this is taking the approach that the web isn't any different. The web is your website, your web application is your web client to your application. It's not a single monolithic web application that both serves that content and renders it. Instead, it's a client to a data service that might be shared between Android, iOS, web, whatever other services you need. The other type of static applications that exist are compiled content. So that's static blog compilers like Jekyll or Roots or Metalsmith or any others. That's things like this slide deck, which is something that I've been hacking on, which uses reveal.js, but is compiled from a markdown file with YAML front matter. I don't know. I've been hacking on it. So static web apps, the reason that I use that term is because it's a broader term that encompasses anything that the target is you're compiling things down to static HTML, JavaScript, and CSS, and any kind of dynamic functionality, any kind of data processing, all of that happens using calls to backend data services as opposed to rendering it onto the page from the first load. So why would you want to do that? Why would you want to take something that's accepted and easy and there's a million ways to do it and sort of stop doing that? The reason that the title of this comes from, this is paraphrasing, I don't remember the exact tweet, but it was something along the lines of single page apps are the fixie bikes of web development. It's giving you all of these constraints, presumably just so that you can look cool for having built something actually useful using it. I'm going to respectfully disagree, but I think that's a funny statement. First of all, there are lots of front-end developers. How many people here are front-end developers primarily? That's at least half of you, maybe more. There are lots of front-end developers, and more front-end developers are able to do more and more. It's not just about, a front-end developer just knows HTML and like CSS. A front-end developer is somebody who is more and more responsible for the end user experience. They're the people really crafting what the application looks and feels like, and business logic as well. And there's lots of them. And this static web application model allows front-end developers to bear a lot more of the work and do it very quickly. Static apps come together very fast when all you have to do to sort of prototype something out and see what it's looking like is basically save and hit refresh, and you don't even have to spin up an application server. You don't have to do anything other than just save a file and look at it in your browser. That's a pretty quick way to prototype. And when you can just sort of stub in fake JSON data that you just write into a variable and you say, I'll hook it up later, that also goes very quickly. We also know how to scale static content. So this is sort of the key difference in terms of performance is that with a traditional web application, caching is always going to be a hard problem. So you have, I'm building this web page, and this little piece up here is specific to the user, but the main article content is something that everybody sees. But then the sidebar is generated dynamically and changes hour on the hour, and you have all of these different things that you're thinking about, and so you have to come up with this complex caching strategy. Am I going to use fragment caching? How am I going to put all of this together? But if you're just talking about files, we're very good at taking files and saying, I'm going to put this file on 20 servers across the planet, and whichever server is closest to the user, that's who's going to get the file. So we know how to scale static content in a way that we don't dynamic content. And while with static web applications, you still have to worry about those other caching problems, you farm those out to services. So my top right thing might be a user service that's cached differently than my sidebar, than my content. And you can worry about each of those independently. And that basically leads on to the fact that static apps are insanely modular. It basically forces you into a service-oriented architecture. So if you're building from the premise that my front end is literally only HTML, JavaScript, and CSS, I don't get to load anything from a database, I don't get to manually, I don't get to control that content other than what JavaScript loads and pulls. It sounds like this terrible constraint, but what it really does is it forces you to think the way that you're going to have to think if your application ever reaches scale. You're never going to see an application with tens or hundreds of thousands of users or millions of users that all runs just on a single monolithic web app server. Eventually, everything becomes service-oriented because different tools and different scaling methodologies are better for different parts of your application. So by separating your front and your back end from day one, you basically force that to happen. You say, okay, well now I don't have this monolithic application. I have my client and I have my data source. And so that makes you more flexible. If you want to take a stab at a completely revamped interface, that's basically just throwing some new HTML together and pointing it at the same data source. You don't have to worry about spinning up special servers that look at user, you just stick it somewhere and try it out. It's amazing how sort of liberating it becomes when you architect your application around the idea that my backend is just a RESTful data source and I just pull from that for anything I need. So it doesn't matter if you're working in web, if you're working on mobile, if you're building a command line client, you're pulling from the same data and you can reuse a lot of the same things, especially if you're doing a lot in JavaScript, as I'm guessing this audience probably does. You can use things like Browserify and have something that works the same way on the back end and the front end. So you could have a library that works with your Angular, that ties into Angular on the front end, or just makes direct node requests on the back end, and it's the same library and you keep it up to date. So how do you make this work? Because if this was something that was easy to do, then we probably already would have done it forever, and that would be the way that we build applications instead of the request response cycle. So how do you make static apps work? It basically comes down to better browser technology. We have browser technology today that we didn't have 2, 3, 5 years ago, and the browser technology today allows us to actually make this work and make static web applications that behave and perform the same way that you'd expect that traditional request response decorated with Ajax, what have you, application to perform. So for routing, you have HTML5 history. You can pop things into the URL that the user sees. You can pull them out without ever having to force a page refresh. There's tons of libraries that wrap that. That's one of the fundamental technologies that lets this work. Crossorigin resource sharing. How many of you are familiar with CORS and what it is? Okay, good portion. So basically, this is cross-domain Ajax. So typically, you are restricted. I can only make Ajax calls to things that are on the same domain as me. And that makes it very difficult to build this kind of application because typically it's going to be, I have API dot versus www dot. Cross-origin resource sharing allows you to make that cross-domain call. And that works in the current versions of basically every browser. And unless you need to support IE 9 or less, you're good to go. I build things for developers, so I don't have to support IE at all. So that's great. And using the with credentials option, you can actually use the cookie data that's stored on your backend server when you're making these cross-domain Ajax calls. And that enables some really interesting things as far as authentication. So you can have this authenticated cookie session the same way that you're used to, except for you're just making API calls and you're getting that JSON data back, all using the same browser session that you're using normally in your application. And if you build a third-party API, you're going to make your API customers very, very happy if you support cores. And there's a few that do now. There's GitHub, the Amazon Web Services APIs support cores. And there's amazing stuff that happens. If you've ever seen, like, here's an alternative interface for GitHub issues that I built in 20 minutes and it's hosted on GitHub Pages, that's enabled because GitHub's API has cores support. So anything you can do with the API, you can do in the browser. And that lets the browser be this amazing coordinating agent for all of these different services. I could pull from the GitHub API and Amazon Web Services and my own custom backend API and Firebase. And I can do all of that using just the browser and not having to parse it all together and send it all through some common endpoint that becomes a giant bottleneck and performance headache. So that's pretty cool. And offline apps. If you've seen the nobackend.org or Offline First, the idea of building applications that maintain the same level of functionality whether you're on or offline, is a really interesting and powerful idea. And that's, again, new browser technologies that are enabling it. It's the HTML5 cache manifest, local storage, session storage, IndexedDB. It's pretty hard to synchronize everything when you get back online, but there are libraries that are working with that, people exploring the problem. It's all very interesting. So what's the hard stuff if you want to build static web apps? Probably the hardest one is search engine friendliness. This is one that I would say is not entirely solved today. Google has their, I don't remember what they call it, but basically Ajax crawlable thing, which is this terrible way of using meta tags and hash fragments to basically tell you that you need to run a headless browser on your server, and when you see this escaped fragment query parameter, you have to render it and then send it out. It's a mess, I'm not going to lie. So if you have something that is like search engine traffic to individual pieces of content is like the most vital thing for your application, this might not be the best architecture for you today. There are solutions coming up. I think this is going to change in the next year or two, but today, not the best for search engine friendliness. Data security is interesting just because if you're doing all of this stuff in the browser, if you're pulling from all these data sources and performing sort of business logic operations in the browser, well, your users can dig in and do any of that too. So users running arbitrary code, what could possibly go wrong? But really, all of that really means is that you just have to be smart about it. You have to be considerate of what you're exposing and how you're exposing it. And a lot of these things are not really less secure than a request response application. They're just more directly exposed so that it's easier for people to dig in and find those exploits. So it'll make you smart about what you're exposing to the end user. Mobile latency. So sort of one of the most common things that I hear when I talk to people about this architecture is, on mobile, you have these terrible latency issues where the first page load, the more requests you have, basically, it kills you every single request you add because the latency may be 2 seconds just to get the first byte of a new file. And by definition, since you're not sending all of that content down in the first request, there are problems there. But what I would say is that we have all of these mobile applications and people don't seem to have a problem with the idea of installing a mobile application, which then basically just makes calls to JSON data services. And so if you design your interface right, if you set user expectations right, and you use things like the HTML5 cache manifests, you can basically have the first time a user accesses your app on their phone, it installs and it maybe has a bit of a load time, but then after that, it works just like a native app on their phone in that all of those assets are cached locally and it's just making data requests. So what are some of the services that sort of help you put this stuff together? There are backend services, so backend as a service, things like Firebase and Parse and Kinvi and Backendless, and there's a few others. And those are really interesting. And a lot of people sort of lump the idea of static apps in with the idea of backend as a service and say that they're basically one thing. So if you're going to build a single page app, then all you need is to talk to one of these backend services, and that's sort of the whole idea. But I would argue that static web architecture is just as powerful, or maybe even more powerful, if you're building your own backend services and still just using those same cores technologies to talk to them. Authentication services, so you can do user authentication using userapp.io, oauth.io. You can make API calls even to services that don't normally support cores using oauth.io. So there are these services cropping up where it's basically drop a JavaScript file into your HTML, and now you have some section of backend functionality that you didn't have before. And I think that that's a really interesting and really sort of, it's sort of a window into where I think things are going, where the browser becomes this coordinating agent, like I said, of all of these different services, and you can basically just pick and choose and drop them in, and you add functionality to your application that way. Then as far as where you're going to host these, DivShot is an option. So is Amazon S3, GitHub Pages, Harp. There's a number of them out there. If you're going to host on S3, I would highly recommend that you put some CDN in front of that, whether that's Amazon CloudFront or Cloudflare or MaxCDN or Edgecast or any of the above. S3 has pretty unreliable latency and other things, but DivShot and GitHub Pages are both automatically backed by CDNs. DivShot also supports push state routing and some other nice things, so that's why I like it. And one last important thing, don't host static apps on Heroku, please. Don't do that. It's generally a bad idea. That's like hiring Elon Musk to like fetch coffee for your organization or something. It's way overkill. You're running an entire web application server just to serve files. And if you serve a lot of files, then you need to buy more dynos, which start at $37 a month. I love Heroku. I use Heroku for all of my backend stuff as much as I can. But it's terrible for static hosting, so just don't do that. So some resources. This is all available on the deck, which I will tweet and hopefully will get retweeted or mentioned by JSLA so that you can see it. Staticapps.org, a lot of the sort of philosophical underpinnings of what I'm talking about here has been written down in more detail there. It's a community resource site. We have a newsletter all about just sort of this static web architecture. The Static Showdown is a yearly hackathon for static web apps that was in February, so it's not coming up for a while, but you could check out the winners because there's some really cool stuff there. Superstatic is our Node.js static web server that actually powers the DivShot web platform. So everything that we're doing with static file hosting, you can do using open source, like it's open source, and we're committed to keeping it that way. So basically, we very much support the open source community that way. DivShot/QuickDeck is the little reveal.js precompiler thing that I'm hacking on for the last week, and it's how I put this together. And Bleigh/Dex is the source for this presentation only for now, but other ones as I add them. So yeah, I mean that's it. And basically, what I'm really hoping is that you'll think about this. You'll decide whether it makes sense to explore this more. And yeah, I'm happy to answer any questions. And just sort of as a shameless plug, if you want $10 in credit for DivShot, just install the command line app and then do DivShot redeem JSLA. And I have some shirts in here, which I was going to say, like, show me a deployed app and I'll give you a shirt, but nobody has laptops and that seems kind of douchey anyway. So if you're I only have 6 shirts basically. So if you're actually going to wear the shirt, come up and ask. I've got larges and mediums, but if you're not going to wear the shirt, give it to someone who will. And stickers too. I don't know. Anyway, anyone have questions? Yeah.
All right, so I'm working on a project right now, and it uses a lot of the methodology that you have here. And a couple of weeks ago, I had the idea to start storing all of these API calls into local storage. And I thought I was onto something new. Apparently not. But how scalable is that? I'm sure I can Google this very easily, but if you have a large content website, can you just keep putting bunches of stuff in there? What's the limitation?
5 megs on local storage. But you can request more than that within, like, first of all, if you're doing any kind of large scale, like if you're doing that on a large scale, use IndexedDB or some kind of wrapper for it. Mozilla has a library called Local Forage that has a very similar interface to local storage, but actually writes to either IndexedDB or WebSQL, depending on what the browser supports. So that's going to be much more performant, it's not going to slow your app down nearly as much, because I think basically from what I understand, all of the browser vendors regret that local storage exists because it has a lot of performance issues. So, but I think that you can use like special JavaScript to request more storage space for IndexedDB, and I don't know where the limit goes for that, but it's probably pretty high, so you could probably do a lot. Yeah.
Clients we work for are very SEO dependent, and can you talk about any of the work that's going on to try to make this stuff a little more SEO friendly?
Sure. So there's a couple of services out there. There's prerender.io, which I'm going to mention first because it's actually also open source. So basically, you can just it works as a Connect middleware that you can just plug into your application and basically serves a phantom.js browser whenever it catches that fragment according to the Google specs. There's also another one called Brombone. We are also, it's on our roadmap to do that automatically in DivShot, or at least have that available to people who are hosting on DivShot. Basically how it works is you have your server set up so that whenever you catch that you put a special meta tag in your HTML, and then you have a special handler whenever you see that escaped fragment query string, and you just spin up a headless browser that makes the request, renders out the page using JavaScript, and then sends that back to Google. So it's doable, it's just really ugly, and you lose some of the benefits of doing static in the first place, because now you can't just straight serve up files. You have to have a server that's smart enough to recognize that query param.
So no matter what, you still have to use Google's version of how this is done. There's no other solutions out there that can...
the only other way to do it is to have some kind of proxy cache or something that's actually... basically the only way to do it is by doing some form of headless browser rendering. There's no standard that says, like, oh, in this case, browsers will actually execute, or search engines will actually execute the JavaScript, which is kind of a lie, because actually Google does execute the JavaScript and fully render your page, because if you look at any time that Google is showing you like screenshots with like the snippets and everything, those are fully JS rendered pages. My guess is that at some point in the next 2 or 3 years, there's going to have to be some kind of reckoning there, because these applications are... like, this isn't like some niche trend that's going away. This is becoming more and more how people want to build applications. And so basically it's going to be in Google and everyone else's interest to figure out a better way to crawl these pages, or they're going to start losing relevance as a search engine. So it's the most frustrating thing for me trying to really adopt and evangelize this, saying, like, if everything is really search engine dependent, I can't necessarily recommend this yet because it's frustrating. Yeah.
Assuming you have total control of the backend, what do you recommend as the preferred workflow for user authentication?
So, basically what we do for DivShot is we have, and I'm a Ruby.js guy, so our backend is a Ruby API, but basically what we do is we have a dedicated auth service, so it's auth.divshot.com. You log in using that. We have like GitHub and Google and password-based authentication. Then that sets a cookie in your browser that's just like your normal kind of user cookie, so it's just the user ID. But that cookie is set to the root domain, so anything on star.divshot.com is able to access that cookie. So then our API, basically how it works is we register all of the applications that we have as if they were the same as if they were third-party applications. So they have like a client application ID, and along with that, they have an associated origin. So this is going to come from dashboard.divshot.com. This is going to come from architect.divshot.com. And when those make AJAX requests, basically, they have a special authorization header that says their client ID, and they pass that with using the with credentials AJAX option. This is getting really detailed and technical, so feel free to talk to me offline. I could go really into depth on this. So, yeah.
You touched on it for a second, but Airbnb has a library called, I think it's render.js, that lets you render backbone views on the server.
Right.
I imagine, is that, if you're familiar, is that to target like the SEO problems?
Yeah, that's entirely, well, so people who do that, they call it isomorphic JavaScript, basically. People who take that approach they'll give you two reasons that they're doing it. The first will be for search engine friendliness, and the other will be they'll give you a line about performance, basically, because like most people are familiar with, for a while, Twitter did like hashbang URLs for everything, and then they like reverted back to serving everything up. And while it's true that like because of the fact that you have to load enough JavaScript to make your first API call, like there can be performance trade-offs there. For the most part, I think that's kind of a straw man argument, and it's sort of very application-specific and dependent, and there are ways around it even if you're doing static architecture. So those are sort of the two reasons, the search engine friendliness, and they'll say like basically render time, the time that it takes for the user to be seeing content that they care about. Anybody else? Cool.
Give it up for Michael.